Hey, I'm Sarah. Today, I'm going to talk about how to set up and use JUnit 5 to test the Ktor client. I'll also go over code coverage using Android Studio and Kover. Let's get started by adding the JUnit 5 dependencies. First, in your project Gradle, add the plugin to use JUnit 5 with Android. Here's a link that you can check out for more information, and this is the plugin that you need to add. And then next, in your module Gradle file, go ahead and apply that JUnit 5 plugin. Once the plugin is enabled, you can add JUnit 5 configuration options. Here, I set the test lifecycle to per class. By default, JUnit 5 creates a new test class instance for each of your functions. This means that if you have 5 test cases inside a class, 5 instances are created in memory. By setting the lifecycle to per class, only one test instance is created, and all of your test case functions run inside that with the same memory ID. You can also annotate your classes on a class-by-class basis, but here I'm enabling the lifecycle options globally. So you just set lifecycle default to per class, and then you're good to go. And let's go down to the dependencies. There's a ton of them. So let me go, okay. So first you need to add the Jupyter JUnit 5 dependencies. Here I add support for parameterized tests and also the vintage dependency for JUnit 4 tests. So here we have Jupyter, we have the engine, the params, and then the vintage engine. Next, add support for launching coroutines in your tests, right here. Then add the MockEngine that Ktor supplies for the Ktor client. This is awesome and really powerful. I'll go into how this works in a minute. And then finally, add the MockK dependency. This library is really easy to use, allowed me to use real code for my unit tests, and saved me a ton of extra typing. So next, let's go ahead and review how my data layer looks and how I'm making these API calls. So if you've seen my previous videos, you've probably seen this before, but let me just go over it real quick. So I have an abstract class that creates my client. I set up a few base constants here, and then I create my client and pass my Android engine. I install some logging, and then I install the content negotiation for the JSON serialization. It's pretty basic, easy stuff there. And now let me go to, let me go to my CityApi service. Let's take a look at that. So this inherits from that Ktor Client abstract class and also from an interface that provides the contract for all of the methods. So these are the routes that are specific to this API service, and I'm using an object here to set all my routes. And this is really helpful because I can use this both in my API service as well as my unit tests. And I'll show you how that works in a minute. So here in my function, it's a suspend function. That's why we need coroutine support. It returns a service result of a CityApi response. And I basically just call my client. So with the client, I call my route, set my API key, and I put the prefix in the URL query string. Then I return a successful response here. So in this CityApi service, each method uses the real API URL and calls my real Ktor backend. So how can we mock this? You won't believe how easy it is. And let me go ahead and show you what I've got here. So let me go down to my unit tests. And I've got a very similar folder structure here, so it's easy to map. And here's my Ktor clients. So let me show you what this looks like. So to set up a mock client, you just need to pass the MockEngine instead of the Android client. And then next, you configure the client engine to listen for a route path, respond with some pre-configured content, which in my case is JSON, and respond with the HTTP status code of your choice. And then you can set the response headers, which again, in my case, is JSON. So here in the engine config, I add a handler, and then I listen for my routes. So again, we saw this object all specified out before in the API routes file. And I can respond with a city success JSON. And let me go ahead and show you what that looks like. So this is a hard-coded JSON string that returns the city API response, which is just a data class that returns my user with app API model, a list of cities, and a list of errors if there are any. So back here, so we respond with that JSON. I respond with a status code of OK, and then I send my response headers, which in this case is just content type JSON. So, and then I listen for a different route too, and this is to get city by zip. Now, if you like, you can still add logging to your client. For unit test, you just need to update the override function to use print line instead of logd. And this allows you to view the same exact logging information that you would see real time in your logs, you can see in your unit tests, which can be really, really helpful. And then finally, I install content negotiation the same way that I do with my real Ktor client. And I've also set up a client to handle the error responses. So this client listens for the same routes, except this time it sends a city error JSON and a bad request as the HTTP status. So again, here I listen for my route, and this is the city error JSON. Again, it's just a hard-coded string, but this time these values are blank, and my error comes back with an actual message that would actually come back from the real Ktor API. And again, I install my logging and install my content negotiation. And this is great, but what if you need more flexibility than that? Well, I went ahead and created this function, and I pass in some dynamic JSON and a dynamic HTTP status code. So I can call these from my tests whenever I'd like and create dynamic clients right on the fly. So here in my engine config, I'm not listening for a route. Instead, it just uses the parameters that I send from my tests. So I can send any JSON, any status, and my response headers. And again, this is all the same for my logging and my content negotiation. So how does this actually work in a test? Let me show you my CityApi JUnit test. And again, this is all JUnit 5. Now for this, I can actually use my real CityApi service that we saw earlier in my data layer. And this keeps my testing closer to the actual business logic of my app. And it eliminates the need to create duplicate services that inherit from my API interfaces and that abstract class that we saw. So MockK makes this possible with the SpyK mock. And first, I just initialize my CityApi service with the SpyK. And then next, this is a JUnit 5 feature. I create a nested class, and I can give it a display name of all of my success responses. And then for my first unit test, I use run test to launch the coroutine scope. Then with the magic of MockK, I use the every block to mock my Ktor client. So here it uses the Ktor success client. So for every call from CityApi service client, which is here, this is going to be mocked with this Ktor success client that we saw that has that listens for these paths and returns this hard-coded JSON. So then I can actually call my real method. It runs the same code as my API service, replacing my Ktor backend with the mock. And then the my results variable should hold the city API response that gets serialized from the JSON that I passed to my mock client. So here we have results is a service result of type city API response. Now for my actual tests and assertions, first I just make sure that the class is in fact a success response. And with JUnit 5, you can do that with assert instance of. And then next, I just simply make sure that the results object that I get back has a city count of 5, because that's how many cities were in the hard-coded JSON. And then for my errors, I create a different nested class. And this time I do the same with the error response, only this time I pass the Ktor error client, which will respond with a bad request. So here, again, I just call my real function, and then I make sure that whatever comes back is an error. So let's see what this looks like. I'll go ahead and run it. And to do that, you just click here, run the test. And I've popped this out in a new window, so it's just easier to see as we run it here. And let's give this a minute to run. So here we go, the results are coming in. And this is the great thing about nested classes. I have a nice structure here where I can just jump through each one of my tests. So I've got the success responses, which is my nested class, and the error responses, which is my nested class. And just to give you a quick overview, especially if you have a new instance of Android Studio, if you don't see your tests, you can just toggle this check mark here up and down. You can expand your results or collapse them. And then basically I can jump right to my success response. Now with MockK client logging, here we go. I've got the request that I sent, which is very cool. And I can go down and I can actually see the JSON that came back from my MockK API. And then for the errors, same thing. I get my log. And I can see here that I have my error response in the JSON. So really cool features. There's one more thing I want to show you. For your JUnit 5 tests, you may need to do something like before each. And then you could create a function to clear all your mocks. I wanted to do this on a more global scope, and I can do this with JUnit extension functions. My real API services use logd to print out debug messages. This causes an issue in the context of my unit test package. To resolve this, I'm using these functions here. I override the before each callback that's run before each individual test. So all you need to do is just before each callback, and then send the context. And then here, I clear all mocks to start over fresh for each unit test. And then I use MockK's mock static to handle all my calls to logd. In my next project, I'll use Timber for a more elegant solution. This works pretty well. I just go ahead and create my log. And then for every call to util logd, it just returns 0. And then this is run globally for all of my unit tests, and I don't have to worry about it, which is a really cool feature. Now let me go ahead and show you my AppApi unit test. I've approached this unit test a little bit different. So here, I do the same thing. I use SpyK and create my AppApi service. I create my nested class to return a success. Now, in my AppApi unit test, I take a more dynamic approach. Here, I create the exact JSON response that I'd like to get back from my MockK client. This was a little tricky for the enum. I had to use reflection to get the serial name. So in this create app JSON success, this basically creates a dynamic JSON string that allows me to pass the unique data that I want, like the user ID, the user app ID, the app name. And it just basically fills in this JSON just like I need it to. And for the enum, the JSON actually expects dev instead of development. So I just created this little helper function that gets the serial name for the value that's supplied. So let me go back to my unit test here. So this creates the JSON. And then next, I build a dynamic MockK client that includes my JSON that I created here and returns a successful response. So for every call to the client, return this dynamic client, pass the JSON that I've defined, and return OK. Now, again, I just call my real API. And again, I make sure that it was a successful response. And here I can actually get the response. So it came in as JSON and it comes out as a user with app API model. This allows me to verify all of the properties that come back in the API model and make sure that they match the JSON that I passed. With JUnit 5, I can group all my checks with a heading and the assert all. So I can make sure this is 5, this is 1, my app name's the same, and everything went okay with the enum serialization. For inserting a new app, first I create the JSON that I want to get back. All new inserts should return an API key from the Ktor API backend. So here I create the JSON response that I'd like to get back with my user ID, the app name, the app type, and the API key. And then next, I create the app detail object that matches the JSON, excluding the user app ID and the API key because they aren't set at this point. So I can just use my real model and set my user ID, my email, my enum, the app name. And again, I create this dynamic Ktor client and I pass the JSON response that I'd like to get back and a status code of OK. And I call my real API and I should get a successful result. And then I save that result to a variable again. And finally, I can make sure that everything came back okay, properly serialized. So this is 5, this is 2, and I can make sure that I have the API key. And then to test the error response, I just create a dynamic client and pass a hard-coded JSON string. So this time, it just uses the string here with the pre-filled error message. And then it just checks to make sure that it's an instance of the error response. So now, when we run this test, let's go ahead and run it with Android Studio coverage. And to do that, you just need to go back up here, and you can say run with coverage. Let's go ahead and wait for that to come back. Okay, and again, that was a success, and let's see how Android Studio looks now. So I get this nice little report over here, which shows me all of my coverage. And as you can see, I don't have too much covered at this point, and you can drill down. So most of my coverage is in my data layer on the remote side because I'm testing the APIs. Let me make this a little bit bigger here. There we go. So let's see. So I've got my repositories, I've got my APIs up here, and we should be able to see, yep, we can see that this is mostly covered halfway. This is almost completely covered. So it's really cool stuff. We can see our coverage right here, you know, without having to add any third-party tools or anything like that. Very nice. And if we come up here, we can see that it's also duplicated here. So I can get all of my coverage information right here in Android Studio. So it's a really great feature. Even though the Android coverage is pretty cool, you may still want to add some third-party tools just to have some more flexibility or maybe integrate it into your GitHub repo or things like that. So I can show you how to use Kover right here. It's really simple. It doesn't require any configuration if you don't need any, but of course you can add some if you'd like. So in your project Gradle, just go ahead and add the Kover plugin. And then in your module, you just need to apply it. Very simple. And then once you do that, go ahead and sync your Gradle, and then you can come into your Gradle tasks, and under verification, you're going to see all of your Kover options: Kover HTML report, Kover report, and Kover verify. So here, I'm going to go ahead and run the HTML Kover report. Once the report finishes, you'll get a link to the HTML report that you can open right up in Android Studio. And then if you just right-click, you can go to Open in Browser and then choose the browser of your choice. So I already have this open. I'll go here and just refresh it. And let me make it a little bit bigger for you. Okay, so this is really cool too. This has a package breakdown. And then we've got our percentages of coverage. And here you can drill down. So let's go to my remote APIs. Now I can see, again, the same coverage options that we saw with Android Studio. And if you actually go into, let's go into CityApi Service, so I can get a nice little report in green of what's covered and red of what's not. And that's really all there is to it with using Kover. It's very simple, very easy to use, and I like it a lot. That's about it for the basic functionality of JUnit 5, MockK, Ktor Client MockEngine, and Kover, but there's so much more to explore. I recommend reading the docs for more features and additional configuration options. I also put some helpful resource links in my GitHub README. In the next video, I'll go over instrumented and end-to-end tests for Jetpack Compose, and thanks for watching.